Hi, my name is Amanda Castillo, and today I will be discussing the special senses with you. I will be going into great detail here about some of the special senses and what they do. I will also be applying some of these special senses to a case study for my anatomy class with Aspen University. My objective and my main goal is to get a to give you guys a good understanding of the special senses and how they're applied. There's a big difference between the general senses and the special senses. I don't know about you, but I always thought, that there was just a general sense. I didn't really know that the special sense was kind of a thing. So this was something new for me, and it was super interesting to get into. So, on a general standpoint for the senses, the central nervous system allows the general senses to detect things such as pain, touch, and temperature with stimuli. The term general here means that these receptors are simple and are located throughout the body in both the skin and internal organs. Whereas, the special senses, they are named this because they convey a particular type of information from specialized sensory organs in discrete locations of the head. The special senses are also able to detect stimuli. For example, things like sound, light, or chemicals. For both, the general and special sensation, the stimuli are first processed with sensory nuclei and then they are transmitted to the thalamus for primary cortex areas for identification and awareness. The human body is assumed to have about six, specialized senses, which include vision, hearing, balance, taste, acceleration, and olfaction. And each requires a special sensory organ, as discussed earlier, to be perceived. However, there is definitely far more, than just six. The body is capable of sensing many other things, such as pain, temperature, the ability to have a kinesthetic sense, and many more, even inside the body. There's, roughly about 25 senses that the body has, not just six. So that's super cool. I always thought, those were just kind of the main six there. So some other main, objectives here that I want to get to is that the special senses all require that special sensory organ in order to be perceived. My main examples today, we will stick to, more of these common six that I said initially: the hearing, vision, taste, balance, olfaction, and acceleration. I'm going to utilize these into a case study to show if these special senses are needed for, the particular situation. The special senses do not work alone. Rather, they collect and report information simultaneously so other areas of the brain can integrate the received information into a picture of the situation that is coherent. Receptors will first detect and transduce the stimuli. The cranial nerves then transmit neural signals to the central nervous system. Next, the neural signals will be relayed through the thalamus, accept signals for olfaction. Continuing on, there will now be an awareness that happens in the primary sensory cortex. Lastly, the frontal lobe and limbic system will integrate the special senses. Each primary cortical area has a great connection with the and limbic system. That allows the body to convert these little tiny bits of information into a meaningful picture that the brain and us, as a person understands, which is so cool. So getting into this case summary here that we're going to do, I'm basically going to apply these six special senses that I chose to this case study. To summarize this case, I want you to imagine that we are driving or biking on a high traffic road. And for my particular situation, I'm going to choose biking on a high traffic road. So once we're biking on this, we are coming up and we are approaching an intersection that has a four-way stop with a railroad train track. Additionally, there are three cars in the other lanes of the intersection, and visibility is decreased due to foggy weather conditions. Our end goal here is to assess what special senses are and are not needed, to safely proceed into this intersection. I'm not gonna lie, being from a small, rural town in Minnesota, I have been in this situation definitely more than a few times. There's not a lot of stoplights in my little small town, so I have to use my own special senses to definitely safely proceed through these tough intersections, especially on a bike, because people are not, as we know, always the most aware of bikes at these kind of intersections. So, um, I believe that in this type of situation, the special senses that will be involved are balance, vision, hearing, acceleration, and the special senses that are not involved will be olfaction, olfaction, and taste. In this particular case study, this um the those special senses that will be utilized by the body in order to cross the intersection safely will be, in my opinion, those four. An individual, needs to be able to accelerate their bike, to feel the bike move forward, feel your body move forward across that intersection. They need to be able to see to make sure, obviously, that it is indeed safe. They need to be able to hear and listen for other cars, car horns, noises that can be associated with hazards in the situation. And lastly, balance in order to, get that bike across safely without falling in front of a car or getting stuck in the middle of the road. So the the body, again, in my opinion, will definitely not need, smell or taste in this kind of situation. So we're going to start for the special sense with vision. Vision is needed, obviously, again, to see the other cars, where the bike is going, to get through this fog, making the visibility difficult, and then overall just make it across the road. It is essential for making it safely through this intersection. And vision is defined as the perception of light reflected by various objects. Using the eyes and visual pathways in the central nervous system help to figure out the shape, size, and color of objects. Having a good understanding of light helps us to understand the special sense of vision. Visible light is known as the range of electromagnetic wavelengths that are detected by the eye. No matter the wavelength, the basic unit of light is known as as the photon, which stimulates the photoreceptors in the retina. When light passes through a translucent object, the rays of a light can bend or refract. If there's a greater angle, there will be more refraction. On a curved surface, when the rays of the edges of the surface strike at a bigger angle, they actually have a bigger bend. A convex lens will have a surface that kind of bulges outward and then causes the rays of light to converge as they pass through. Once the rays do converge onto a point, known as the focal point, then this is when it is focused. A concave lens, on the other hand, causes rays to diverge, spread apart, and it makes it difficult and doesn't allow to really focus. For clear vision, the rays of light must focus on the retina. Rays have to be refracted to converge and to be able to focus on your retina. The cornea and lens provide refraction. The cornea focuses on incoming light into the retina and serves to protect the eye. A combination, pupillary constriction and convergence will help the eyes to see up close. Some conditions can interfere with the rays focusing on the retina, such as presbyopia, monopia, hyperopia, and astigmatism. Excuse my pronunciation there on a couple of those. Moving on with vision here, the retina part of the eye, has those rods and cones, bipolar cells, retinal ganglion cells, amacrine cells, and horizontal cells. Hyperpolarization of cones and rods gets rid of inhibition and of bipolar cells, which then increases the release of excitatory neurotransmitters onto the retinal ganglion cells. The axons of the retinal ganglion cells from the optic nerve bring visual stimuli to the brain, which is so cool. I love that we have this kind of connection for immediate, reactions there. Axons from the lateral geniculate nucleus make optic radiations and terminate into the primary visual cortex. Conscious awareness and initial analysis will start here. Color and shape analysis happen in the temporal lobe, and analysis of movement actually takes part in parts of the parietal lobe. This makes the special sense vision as, again, essential for making it into that intersection safely. You need to be able to see and analyze all the surroundings to make a decision kind of moving forward with this bike into the intersection. Onto the special sense of hearing. Hearing is obviously important to hear noises around the intersection, such as car horns, other cars, people walking, and other hazards. This will be essential to crossing safely into the intersection. In order to hear a sound waves have to get into our inner ear and be transduced into neural impulses that are sent through the vestibulocochlear nerve into the central nervous system. Sound waves go through the auditory canal and are able to trigger vibration of the tympanic membrane, auditory ossicles, and oval window. As vibrations go through the scala media, they also vibrate the basilar membrane where the spinal organ sits. Hair cells move with the basilar membrane against the tectoral membrane, and this, then causes the stereocilia to bend. When this bending occurs towards the tallest stereocilium, it depolarizes the hair cell, and then in turn, when it bends kind of the other direction, it hyperpolarizes it. The receptor cells translate their movement into the nerve impulses with the vestibulocochlear nerve to the brain, where now this is where our body kind of perceives this as sound. After information is relayed to the brainstem and to the medial geniculate nucleus of the thalamus, the auditory stimuli arrive at a primary auditory cortex in the temporal lobe for conscious perception. At this point, signals travel to other areas of both the temporal and parietal lobes, as well as that lymphatic system. To cross this intersection, I will be utilizing the hearing, to be aware of my overall surroundings and to make sure that it's safe. Hearing, is used in our everyday lives to keep us safe and aware of things constantly going on around us. Obviously, we also use hearing for communication, listening to music, and many other things, but especially in this case study here, hearing will be super important to make sure that everything's safe around us. Now onto the special sense, of balance and that idea of equilibrium. The special sense of these will be a critical part also into making it safely across into this intersection. Balance is used to help us keep that bike balanced so we obviously don't fall over, and detected with mechanical receptors in the semicircular canals. It helps us to maintain body posture and stability. Nerve impulses that are generated with receptors and canals are transmitted to the vestibular nerve. And here the signals are able to be processed by the brain. Those semicircular ducts are able to detect rotational head movements. An ampulla at the base of every semicircular duct houses what is known as the crista ampullaris, which is where, those hair cells are located. The stereocilia and curiocilium are embedded into that gelataceous cupula. Rotating the head pushes the endolymph against the cupula and then in turn bends that stereocilia and ciliocilium. This means again that it either depolarizes or hypopolarizes the hair cells depending on which direction that kind of rotation happens. This